All right, welcome back. So YouTube apparently cut off this stream because I was displaying copyrighted material. I'm not sure why it thought that, given that there's clearly no copyrighted material and there was also no soundtrack. But here we are, hopefully working now, and we'll get started. So welcome everybody. It is day 15 of remote learning. We have, well, I guess it's Monday, it's day 15 of remote learning. And today, in honor of the weather, we have a bad joke as usual. And this one's bad joke is, what is a snowy owl's favorite kind of math? Algebra. Yes, terrible, as usual. So welcome everybody, happy Monday. Solve that like button to show your support. In today's lesson, there's a short survey for you to give me some feedback about the live streamed lessons. What did you like? What would you like to see me change? What suggestions do you have? So please let me know. Constructive feedback is really appreciated. I know it's easy to just say, oh, it was good, but if you can. But today we're going to look at how to write an equation or two equations for two lines that are parallel, or two equations for two lines that are perpendicular to each other. So that's our goal. We're looking at page 437 in the textbook for the questions, and I'll try to post a copy of that page online for you right after I close the stream down, because I realized I forgot to do it beforehand. So let's get right into things. Give me a moment to get this adjusted. All right. The other thing I'll say is that we had, in the Google Classroom, there's a link that goes to Desmos. If you could open that up, we're going to be using that to visualize things. It's going to help us to understand what's going on here a little bit better, and also to see some examples. Okay, so parallel and perpendicular lines. I'm going to zoom in. There we go. Yeah, and the most important thing that we want to say is about their slopes. So if we have two lines that are parallel, what can we say about their slopes? Hopefully it'll catch up. I'm going to try and keep the lesson pretty short, and that way, if it is really hard to watch twice, I'd like you to change the first one to the line y equals 2x. So your top one, you should have y equals 2x, and your bottom one for now, you can leave it as y equals x, the blue one. All right, and you'll notice now you can see both lines. They're crossing each other at the origin at the point 0, 0. We're going to make one more modification. So in the bottom line, we're going to make it y equals x plus 1. So now you'll notice the two lines are still crossing each other on your Desmos, but they're not crossing at the origin anymore. The top line has a y-intercept of 0. The bottom line has a y-intercept of 1. So my challenge to you is take 30 seconds and see if by putting a number in here in the slope for the second line. So put in any number you want, play around with it, see if you can get it, so that you can get the two lines to be exactly parallel. Don't change anything else. Leave your first line as y equals 2x. Leave the plus 1 for the y-intercept here. Just change the slope. Put in any number you want. Right now it's an invisible 1. You can put in any number you want and make it so that the two lines Just trying to clear up the live stream here a little bit. Closing some tabs on my browser to see if that helps. Okay, let me know if that's better. So I've closed down some of the browser tabs that might have been taking up more of the CPU time. So hopefully that's okay. Cooper, I see that you're saying there's also a big delay. Yeah, I noticed in past streams that were sort of anywhere from like 5 seconds delay up to even 25, 30 seconds sometimes. Seems fine for now, Jackson. Okay, other folks, are you able to see things a bit better now? If I continue here, if there's some movement in the screen, it's okay for you also? Good for you too, Alan. Okay, so hopefully then the problem was just a product of having too many other tabs open. Okay. All right, so I think we're going to keep going. It seems like the stream is a little bit better now. So yeah, Jackson, I'll start from the beginning again. So we're talking about parallel and perpendicular lines. And we've previously talked about parallel lines for angles. But today our goal is not to talk about angles. Our goal is actually to talk about equations of lines. And if we have two equations for two different lines, how do we check whether those two lines are parallel or not? And how do we check if those two lines are perpendicular or not? So that's our goal. So if you open up the Desmos link that's in the classroom lesson, so the day 15 lesson, the second link there says parallel and perpendicular example, and it's a link to a Desmos page. So if you open that up, you'll notice that there's two lines already in there. They're both y equals x. And I'd like you to change them. So I'd like you to make the first line y equals 2x plus 0. You don't need to put the plus 0 because it's automatically there. Or it is automatically 0 if we don't put anything. And the second line, I'd like you to make it y equals x plus 1. So 2x and y equals x plus 1. Okay, so hopefully that's making sense, and I'm not seeing any more comments about the stream freezing, so it looks like we may have solved that problem. All right, so what I'd like you to do now that you have y equals 2x as the first line and y equals x plus 1 as the second line. Right now, the slope for the second line is this invisible number 1, right? We don't put anything there, which means it's an invisible 1. I'd like you to try filling in a number in that spot to get it so that your two lines are parallel. Don't change anything else. Leave the first line as y equals 2x. Leave the y-intercept of the second line as 1. Just change the slope of the second line and see if you can make the two lines parallel. And when you get a slope here that you think makes the two lines parallel, just type that slope into the chat. So I'll give you a bit of time to try that now. Hopefully that's making sense. Thank you, Cooper. Thanks, Sabrina. Get a couple more answers in chat, and then we'll keep moving. Anybody else find one that works? Cool, thanks Emma, thanks Jackson. All right, so folks have found that if we put a 2 there for the slope, that we get 2 lines that are parallel. And so you're noticing, hey, if there's a 2 up here for the slope and a 2 here for the slope, I get parallel lines. So maybe it's that slopes that are the same make lines parallel. So I'd like you to try this out. I'd like you to make now any slope that you want for the first one. And for the second one, do the same slope. And I'd like you to actually do a fraction. You can use the slash key that's next to the right side shift on your keyboard to make a fraction. So you can do anything you want, 2 over 5, 34 over 800, whatever fraction you want. But I'd like you to try the same fraction for both lines in Desmos and see what happens. So test it out, pick any fraction you want. And if you can type parallel in the chat, if you find that the 2 lines are parallel, and not parallel in the chat if you find that the 2 lines aren't parallel. Give you a moment to do that. Same fraction slope for both lines. Wow, it does seem like we're having a really long leg today. Hopefully that won't last. So again, once you've put the same slope in for both lines, just type parallel in the chat if they're parallel, and type not parallel if you find that they aren't parallel. Thank you, Emma. Thanks, Sabrina. Thank you, Jackson. All right, so folks are finding that they are parallel. And in fact, that kind of makes sense, right? Because the slope tells how much to go up and how much to go over, making that line. If you started that from somewhere lower with a different point, it would still tell you to go up and over the same amount if you have the same slope. And so you will get 2 lines that are parallel to each other. All right, so let's write this into our note. 2 lines are parallel if and only if they have the same slope. And so our examples here, y equals 2x plus 0, y equals 2x plus 1. And you can put whatever fraction you use, x plus 0, 2/5 x plus 1. Oh, really blurry. Stream is freezing again. Frustrating. All right. All right, I'll check if there's anything else I can close here. Maybe speed it up or make it a little bit better. Okay, so I've closed a few more things. Hopefully that will help. All right, so let me know if that's a little bit better. We have our two examples here of parallel. So I'm going to very quickly, before the stream blows up any further on us, try to deal with perpendicular. Still looks the same. Okay, well, the good news is that the lag seems to be lower. So that's helpful. All right, I will try writing a lot bigger. So this word that I just wrote is the word perpendicular. And then I'll do everything else double size like last time, so it's a little easier to read. So 2 lines are perpendicular if, and so we were going to do an activity to try to discover this, but I think if the stream is bad, I'm just going to explain it and that will be easier. So if you go into your Desmos, and I'd like you to make the top line y equals 2/5 x plus 1. Okay. 2/5 x plus 1. And the second line, I'd like you to make it y equals -5 over 2 x plus, and you can make it +0, +2, +4, whatever number you want. Maybe pick a small number so it just doesn't go off the graph. You should see, if you look at these two, so a line with a slope of 2/5 and a line with a slope of -5/2, is that they end up being perpendicular. So if their slopes are, and the technical term is negative reciprocals. There we go, negative reciprocals. Okay, I see it's freezing as well, Alan. If this gets too bad for you, feel free to just drop off the stream and then watch the video on YouTube. Hopefully the YouTube version isn't freezing up. And if the YouTube version is in bad shape, then I'll just do a re-recording of this onto my own computer and upload it to make sure that it's reasonable. So perpendicular line slopes are negative reciprocals. Negative means that if one of them is positive, the other one's negative, and vice versa. Slope is a negative number, your second one's going to be a positive number. Reciprocals means that they are flipped fractions from each other. So 2/5, the reciprocal of 2/5 is 5/2. All right, so this is negative and it's a reciprocal because it's flipped. The denominator is now in the numerator is now in the denominator. So some examples of that, 1/3. If we flip that, we get 3/1. We have to make it negative because this first one was positive. So 1/3 and -3 are perpendicular slopes. And you can go into the Desmos and try changing your slopes to 1/3 and -3. And you'll see that you once again get two perpendicular lines. And as another example, negative, let's try 3/4 and 4/3 are perpendicular slopes as well. Since the first one's negative here, the perpendicular is going to be a positive number. And you can play around and try this out, and you'll see that it works right across any slope that you pick. So pick any slope that you want, find the negative reciprocal, put that into Desmos, and you'll see that we get perfectly perpendicular lines. So two quick questions then. The first one is, why is that the case? Well, the slope tells us the amount that we go up and the amount that we go over when we're drawing the line, right? It's the difference in the y, which is how much we're going up and down, divided by the difference in the x, which is how much we're going side to side. If you flip it, the amount you're going up and down becomes the amount you're going side to side, and the amount you are going side to side becomes the amount you're going up and down. And so we're going to take a look if we have a triangle. And I'm going to use this here as my triangle. So if I have a triangle set up, and there's an up and down amount, which is this long side, and there's a side to side amount, which is this short side for this line here. If I rotate this 90 degrees, now you can see the side that used to be up and down is now my side to side. And the side that used to be left and right is now up and down. So that's why it makes sense that when we do a 90-degree rotation to get up to be the side that's up and down and vice versa. So that's why we do the flip. The negative part happens because if a line has a negative slope, it's going down to the right. When you do the perpendicular, it's going to have a positive slope going up to the right. So that sorts for you why it works that way. We're going to do one example as we wrap up here. So example. And the question we're going to ask is, for two lines, are they parallel, are they perpendicular, or neither? Parallel, perpendicular, or neither. There we go. So let's try it with y equals, let's go with 4x plus 18 and y equals 1/4 x minus 7. So are these lines parallel, perpendicular, or neither? Well, we're going to look at the slope. The slope of this one is 4. Is that the same as this one? No, this one's 1/4. So they're not the same slopes. So now I know it's not parallel. Are they perpendicular? Well, 4, if we made that into a fraction, it would be 4/1. If we take the reciprocal, we flip it over, we get 1/4. So these two slopes are reciprocals of each other, but they're not negative reciprocals. They're both positive, neither one's negative. So these are not negative reciprocals of each other. So it's like close to what we need for perpendicular, but it isn't perpendicular because this one isn't negative. If this one was negative or this one was negative, but not both, just one of them, if one of the two was negative, then these would be perpendicular. So these are going to be neither. And if you graph these two lines in Desmos, you can see that they're in fact not parallel, perpendicular, or neither. So I'm going to leave it at that. I'll stay on the stream for about another minute or so in case people have questions. For these answers, I would recommend, instead of using the back of the book to check your work, just keep a tab open with Desmos, and after you've answered a question, type the equations of the lines into Desmos and see whether you get actual parallel, perpendicular, or neither. Okay, so we'll leave it at that. If you have questions, I'll stick around for another minute or so. You may need to rewatch the video if it's been freezing or blurry for you, and see what you can get. If you do find that it's so blurry when you rewatch that it's not making any sense, let me know, send me an email, and I'll see if I can re-upload a better version. Okay, I'm not seeing any questions in the chat. Hopefully that made sense. Sorry that we didn't have a chance to go into some more detail on it, but hopefully that was okay for you. The other resource you might find helpful is the pages 434 through 436 in your textbook. They have a really excellent explanation of this as well. So we'll see you on Wednesday, and I'm going to see if I can change my internet setup to make things a little bit better. Take good care.